Hello, and welcome to my poster presentation. My name is Somto Chukwu Ufondu, but you can just call me Somto. I recently graduated from the University of Saskatchewan, where I got a master's degree in geophysics, which is under the Department of Geological Sciences. And my supervisor was Professor Sam Butler. And the poster presentation that I'm sharing with you today is what I did for my thesis while I was at the university. The title of this thesis is Digital Rock Physics Modeling of Carbonates and Sandstones. So we built an experiment in a software called COMSOL Multiphysics, where we simulated some stress and strain on some rocks. And we did that by importing the X-ray tomography of the pore space of these rocks into COMSOL, and then subsequently perform these numerical calculations on it. The reason why we did this was basically to calculate the BIOS parameters. The theory of pore elasticity defines how porous solids deform under applied stress, and also seeks to understand the relationship between the porous fluid and the solid skeleton during deformation. This was first introduced by Bio in 1935, and over a number of years, he went ahead to write several papers on several types of deformations of anisotropic solids. Bio's theory, which contains a few extra parameters compared to the regular solid mechanics, allows us to calculate the strain on a porous rock given a certain stress when the pores are saturated, that is completely filled with fluid. In other words, the Bio's theory considers the whole rock as a continuum. And this is what, in this study, we term macroscopic theory. Or when we say macroscopic parameters, that's what we mean. We're considering the whole rock, the rock as a whole, as a continuum. And then when we say microscopic, we're considering the rock, the pore space separate from the solid skeleton. So when you go through my poster, you will see some of the results we got from this calculation and how we compared that to the Gassman's equation. And also you would see some plots of the energy signatures in these rock models in COMSOL, and also the plot of the normalized average energy density of these of the several different models. In this study, we were only able to get 3 carbonate samples and 2 sandstone samples, all of different porosities, and we showed that in the results as well. And for our simple 3D models, we were able to do different types of 3D models, but I was only able to show one of them, the results from one of them here, which is the spherical rock, and with one spherical pore. We did several others, which include different number of pores in them and different shapes of both the solid skeleton and the pore space, and we got interesting results as well. But I'm only able to, I only decided to show a few on this poster, just not to clog up the poster a lot. If you have any questions, I'll be here. I'll be happy to take them right here. But if you'd like to reach me at some other time, my email address is showing right here. Right. Thanks for listening, for watching, and for viewing the poster. Bye-bye.